In this video, you will learn to use Epsilon Axis. Epsilon Axis is a tool that allows you to visualize the aerodynamic reference system. Basically, Epsilon Axis is a filter that can be applied on the top of Epsilon aerodata. It allows you to visualize the aerodynamic reference frame. Indeed, in most of the cases, this reference frame is different from the mesh reference frame that is associated to the CFD simulation. And having access to the aerodynamic reference frame will allow you to interpret all the aerodynamic components like the U, V, W velocity components that are referred to the aerodynamic reference frame in Epsilon. So this is mostly a tool that suits for beginners that are not used to the aerodynamic reference frame, and they may struggle to interpret the U, V, W components in this reference frame by using the mesh reference frame that's actually displayed at ParaView. So if you're already experienced with Epsilon, you don't really need this tool, but it's quite useful for beginners with Epsilon. And I also used it a lot for communication purposes because all the aerodynamic components are referred in this reference system. So it's quite convenient to put this reference system in our communication images. In order to understand how it works on the background inside ParaView when you execute Epsilon Access, we have to understand first the type of data that enters into this filter. In our case, the data that we are gathering is basically the field data. In particular, I read the following information: the angle of attack, the angle of side slip, most importantly, the transformation matrix. So this transformation matrix is very important because it gives me the information that allows me to compute the transformation from the mesh reference system to the aerodynamic reference system. So let's see how it works inside ParaView and how Epsilon Access manages to generate those reference systems. Well, the first step is to read the field data from the input. Basically, it just gets the transformation matrix information that is available at the field data inside Epsilon aerodata. The second step is to generate a reference arrows. Basically, it uses BTK operations to generate 3 arrows that are aligned with the mesh X, Y, and Z axis. Of course, these are BTK operations, and you can even edit the Python files in order to generate your custom geometries if you want it. And afterwards, we have to rotate the arrows. Basically, we take the transformation matrix that we read from Epsilon aerodata, and this allows us to transform the set of arrows that we generated before that were aligned with the X, Y, Z mesh axis. And after the transformation, we rotate that, so these new arrows are aligned with the aerodynamic reference system. And that's all. Basically, once we generate the rotated reference system, the rotated arrows, we just output data as a BTK polydata. Basically, all the steps that I showed you before are integrated inside the interface. So let's see how use it and how the interface works inside Epsilon, inside ParaView, in the following example. Well, now we will apply the filter corresponding to the generation of the reference system. This filter is here. It's called Epsilon Access. And basically, it will be applied on the top of Epsilon aerodata. So I have prepared the test case that we already studied in Epsilon aerodata. That is, I loaded these cases that you have in the open data. The NACA 12 airfoil, this is a 2D simulation with 10 degrees of angle of attack. And I already executed Epsilon aerodata. So now we are ready to apply Epsilon Access. And first, make sure that you have selected Epsilon aerodata. It must be blue. Blue is the active element in ParaView. And once it is blue, you can apply the filter. Let's go for Epsilon Access. Basically, you should have some parameters to modify. It's very simple. Let's apply first, and let's see what we get. First thing first, do not forget to click here to change the 2D interaction mode to the 3D. That will simplify the interaction with the object. And then I will change first the background of Epsilon Axis. I will color it by the static pressure field coefficient. And then, as you can see, you have in orange the aerodynamic field that corresponds to the static pressure field. On the top of that, we have two arrows. Indeed, there are three arrows. I will turn the case on the other side. Now you can see the three arrows. And these three arrows correspond to the aerodynamic axis. If you go back to Epsilon Axis, you will see that there are just two options. The first option is the vector size. The actual chord of the airfoil is 0.4, so let's put something small, let's say 0.2. And when you apply, it generates a smaller arrow. And the origin position allows you to translate the airfoil, the reference system, if you want, let's say minus 1.2, 0.2. And this allows you to reposition the reference system in a place where it doesn't annoy to the visualization. Let's use it like this. Okay, and that's how you have to modify the parameters in order to position just the reference system. And on the top of that, you have the colors that allows you to better understand what's the meaning of each one of the axes. You know, the axes here correspond to the mesh axis. You have the X, Y, Z mesh axis. Instead, these axes are the aerodynamic axis. And in red here is X, so here in red is X as well, and yellow here is Y, and the same here. In Paraview 5.9, unfortunately, the Z-axis is not green. It appears blue, but in 5.10 it will be green. So you will have the same color code as here, but this is mesh axis, and this is the aerodynamic axis. As you can see, this case, 2D case, has been prepared with an angle of attack of 10 degrees, and this is actually the angle between the, let's put that, it will be easier to see, the angle between the aerodynamic x-axis and the mesh x-axis is exactly 10 degrees. And it actually generates the aerodynamic reference system automatically because it reads this information. If you go back to Epsilon Aerodata, you generate a new layout, and then click on Spreadsheet View. You will see in Field Data here, you will see that somewhere you have the angle of attack. Yes, here, angle of attack 10 degrees. So basically, Epsilon Axis, when it's applied on the top of Epsilon Aerodata, goes search for that information, and when it generates the aerodynamic reference system, it generates a rotation of about 10 degrees. Now that you have generated the aerodynamic axis, you can better interpret the velocity component. For example, if I go back to Epsilon Aerodata, in aero components, these are all aerodynamic components. For example, you have aerodynamic U, B, and W velocity components. And these components are referred in this reference system, not in this. You will actually better understand that because, for example, the velocity component normal to the plane will be 0. In the aerodynamic reference frame, the normal component is the Y component, so the velocity B, sorry. And you can see the scale is almost minus 15, minus 14 is 0. Basically, it's just a numeric error that you have here. If I put that in a scale, a reasonable scale, let's say 100, it will be actually 0. Everything is green in velocity component, so you have 0 normal velocity component to the plane. Again, this is B. That means this is velocity component aligned with this yellow arrow that is normal to the plane, and it is coherent with this reference system. But if you say B velocity component in the mesh should be the vertical because it's the Y component. So it will be senseless to analyze the U, B, W velocity components in this reference system. And the same happens, for example, if you analyze the exergy components. Exergy components are just a way to understand drag. You have, for example, U and EV. That's the axial exergy and transverse exergy. Axial exergy is expressed along this reference, along this axis, sorry. And in the same manner, EV are the velocity components in the transverse plane. But again, these are expressed in this reference system. So that's the major interest of having this reference system, because it will allow you to better interpret all these components here. So that's all. That's Epsilon Access. Thank you for watching.